So hopefully the break, the coffee, and Tower of Power helped wake you up for an afternoon session. And hopefully I'll keep you awake for this session. So this is Azure AD Password Protection, as you can see on the slide here. I struggled for a little bit coming up with what I thought would be a good subtitle for it, and it came up with Defending Your Organization Against Its Own People, because that's part of what we're doing. We're enabling users, but we're also trying to protect the users, protect the organization against the people that use it. So I am Sean Deuby. That's my Twitter handle, Shore and Sean. I'm a senior architect with Edgile, which is an identity and access management and security consulting firm. I'm one of the leaders of the Microsoft practice there. I've been an MVP a lot of times for what is now called enterprise mobility or directory services. And like a number of people in this room, and you feel free to steal this line because I stole it from somebody else, is I've been doing Microsoft Identity as long as Microsoft has been doing Microsoft Identity. So I spent 10 years at Intel and helped design and deploy Intel's Active Directory. And although when I worked at Intel, I couldn't actually say that. At Intel, we weren't allowed to say that Intel used Active Directory, which is hilarious. Anyway, I can now say that. And before that, I deployed NT 3.5 and 3.5.1 around the world for Texas Instruments. So long history. A stint as a technology journalist, which is one of the places that I met, for example, Darren. And so Darren and I both have a lot of articles out on the web. And I am a proud DEC Wookly Pro-Am Challenge alumnus. And for those of you that attended DEC, you know exactly what that means, and it was sort of the expanded version of what we're trying to get done here. So what am I going to talk about? First one is near and dear to everybody's hearts: passwords must die. It's almost like in any security presentation, they have to put at least one scary slide up there. But in this case, something like this, it's about passwords. And I've spent a little time talking about the updated password recommendations that have come out from NIST and from Microsoft. I assume that many folks are familiar with that by now, but it's helpful to go over it. A little bit about password spray. It's been talked about in more detail by others, and that's fine. As long as you're aware of it, that's kind of really what counts. And then dive into Azure AD Password Protection, this new service that was released a public preview in August, and frankly has not gotten a lot of fanfare, but I'm singing it to the high heavens to anybody that will listen. So that's one of the reasons I'm doing it here. And a little bit about Smart Lockout. I'm preaching to the choir here. Passwords by themselves are simply no longer defensible. You can't construct a password strategy that a machine can't crack in seconds. It's just the way it works. The shared secret thing, as Pam was talking about this morning, it was for a certain time, but it is no longer. Reiterating what the other Sean said this morning, in August alone, Azure AD blocked, or rather broader, not just Azure AD, but the Microsoft Online Services, blocked 1.3 billion credential attacks in 1 month. I love citing these statistics because they're just so mind-bogglingly huge. So of that,
I couldn't log in.
Yeah, that's right. Yeah, have you checked have you been owned, Gil? So compromised credentials, 91% of successful attacks from phishing. And what do they get? User ID and password. 53%, over half of security professionals reported targeted spear phishing to trick the user and harvest user ID and password. This is crazy. 73% of passwords are duplicates. How many here can say that they don't have any duplicate passwords anywhere? Well, good for you. I use LastPass, and I've long since bowed down to my robotic master and just have it generate these really gnarly machine, 15, 20 character. That's a good way to discover the password limitations of the websites. Yep. They go, oh, I'm sorry, I can only do 8 characters. And anyway, I still have a ton of. Do you have like 100% on your security thing. Oh, check you out. Wow. I'm going to buy you a beer later. So it's already paid for, but it's easy. Anyway, and 50% of all the users use the top 25 common passwords, which just is astounding.
Wow.
Wait till you see what they are. So we're all security professionals, as I learned. Don't stand in front of that. We're all security professionals, and we like to think that we roll with the new information and we act on the new information, and we don't, bury our heads in the sand. But password policies are really quite near and dear to the security professional's heart. They've been around since God hung the moon. You're all signed in with the expiration and what the complexity requirements are. You got to have that, got to have the complexity requirements enabled. You're very specific about the length and how long before you do lockouts. Well, you're out of date. And you're actually a couple years out of date because of some of these studies. NIST and Microsoft have both come out with a comprehensive set of recommendations based on real live research that shows how these things actually work and how these policies actually fail in the real world. Now, grant you, these password policies were designed for the Identity 1.0 world, Active Directory in a domain, in a data center, not really designed for the world of the web. But we keep using them, and we use Active Directory policies the same way. So yes, NIST 863B, as an identity professional, you guys need to be familiar with this. And in the deck, I have all the references at the back with the URLs and everything. So the FTC's CTO blog, again, saying it's time to rethink password expiration. A couple of studies by Carleton University and UNC Chapel Hill did analyses on password attacks to see what these effects these policies have on password attacks. So what does the research reveal? First, don't expire passwords. Second, don't enforce complexity. Third, require a minimum of 8 or up to at least 64 character passwords. So, most identity systems do 8, no problem, but most can't do 64. And they can't do spaces and Unicode. So you could theoretically, with this recommendation, you could use an emoji as within your password. Now, how you would do that, I have no idea, but it's Unicode, so it's possible. And in the reasoning about spaces was disallowed to prevent buffer overrun attacks, right. But modern identity systems handle that in better ways. So the ability to allow spaces is something that they're recommending. And to don't change passwords after compromise. That's a real controversial one. And I'm neither here nor there on this. Don't shoot the reporter. I'm just reporting out what's being said. And I'll talk about it. And of course, the reason that you're sitting here is ban common passwords.
Do you know what the reasoning is for not changing them after a compromise?
I'll cover that.
Thanks.
Yeah. But the bottom line and this whole password thing is that it's the wetware. It's what the human brain can encompass and manage versus what machines can do. We can't keep up with the complexity required, and as a result, we fall into patterns. So as you enforce more and more restrictions on Homo sapiens, what happens is they fall into more and more predictable patterns. And that's what shows up for the upcoming examples. And as it gets more complicated, the predictability goes up and the quality goes down. So let's take the first example of the recommendation of not expiring passwords. Frequent change equals simpler passwords and highly predictable passwords. Pass at word 1, pass at word 2, 3, 4, 5. And it doesn't increase the security. Most of us have password lifetimes, 42 days out of the box, as low as 30, which is really annoying, as high as 90. But the attack kill chain happens in 48 hours, an account is compromised, a day or two or maybe a week to domain dominance. And after that, the game is up. It doesn't matter if the passwords change. They already have domain dominance. They can always, well, you see what Michael was doing this morning. It's too slow. Oh yeah, so you know, a cloud-based offline attack against a DIT can do 7 to 10 billion guesses per second. That's a really big VM, but how do you defend against something like that? Microsoft itself no longer has a password expiration policy for new Office 365 tenants. Spin one up, do a trial, you'll see it's turned off. And for protection purposes, MFA is far, far more protective. Far more effective, rather. Complexity, it's the same thing. So the way the human copes with complexity is we fall into predictable patterns. Yeah, I love that. Appendix A of 863 is all about the strength of memorized secrets. And when you think about an Active Directory database, what is the default setting for a number of passwords remembered? 25? Something like that? Well, but you see, that makes it even easier for the attackers. Because once they've got the database, they have the password patterns for everybody that's in there. And they can very, very easily guess what the next pattern was. So one of the reasons behind saying don't change password after breach is if they've well, you don't know. You have to presume that they've exfiltrated the DIT. They know what the next when the password changes, they know what it's going to be. Now you could also argue, you know, as my wife might say, can't hurt, might help. Although having everybody in the organization change their passwords definitely qualifies as some degree of hurt. So here's an example. The University of North Carolina, Chapel Hill did a study with a database that had about 15 old passwords in it. So what they did is they cracked the easy ones first, and then they used those that they got to fine-tune their algorithm to crack the rest more quickly. And I'm sure that that's what modern cracking systems do. Yeah, and in an online attack, 17% of accounts had their next password guessed in less than 5 guesses. So, this is the world's tallest man and the world's shortest man standing next to each other. So here, and for password length, this is a little bit of a Microsoft and NIST vary just a little bit. NIST says that password length has been found to be the primary factor in characterizing password strength. In other words, the longer the better. Microsoft says that excessive length requirements can result in predictable user behavior. So here we go, there's this balance again. What is and this is why, of course, you probably immediately think passphrases, right? You know, as a way of doing it. And what we're seeing in the time since this has been out, recommendations are trending more towards passphrases with less complexity associated with it. Again, with a passphrase, it's hard to iterate those. So one of the things to take away from these recommendations is, if not entirely, they're mostly of a whole cloth. In other words, don't just never expire passwords and don't do anything else. Don't just ban common passwords and don't do anything else. You really have to kind of attack all of these things at once. And so, you know, the threat model, if it's an offline attack, the longer the password, the better. But, I mean, the reality is all bets are off on an online, you know, what is it, 7 billion guesses per second or something like that. All bets are off. So don't change passwords on compromise, the controversial one. So in an identity system compromise, what happens is, let's say a compromise is discovered and the bad guys are in there. So if you do a mass change of password for everybody, but if they've already been in there and you don't know how long they've been in there, you don't know what they've exfiltrated, they already have the identity database. And they can do things like inject SID history and all that. So you have to weigh the, you could almost argue in the position of a security administrator or a CISO, you could almost argue that it's security theater, because you don't really think it's going to help very much, but you know that the executives are demanding that something be done, and you don't want that just to be your resume on the front door. So to me, that's one of the last things that I think is going to be adopted for quite a while.
John?
Yes?
So I think one way to get around that is...
But you're here to talk about, or to hear about common passwords. So this is one of the, as we're seeing, this is probably the easiest recommendation, or one that has been most, one of the most effective things you can do to increase your security. But the problem has been, there's no way to do this with Active Directory, before a couple months ago, without getting a third-party custom password filter. But anyway, so obviously the easy passwords, the common passwords, are the first ones to be compromised. So 10 million breached passwords, the top 25 comprise 50% of the 10 million passwords. And they're the ones like you're seeing here on the right. Those are actual out of the top 25. But 17% fully use 1, 2, 3, 4, 5, 6. And if I'm not mistaken, I think that was the PIN that Pam was using in one of her YubiKeys this morning. So she's part of the problem. Don't tell her I said that. Yeah. Oh yeah. Don't tell her I said that. Yeah. It wasn't as secure as 1, 2, 3, 4, 5, 6. Most cloud services don't check this. Yeah. So this is my one slide. Actually, I've got 2 slides on password spray. And I think of password spray as a brute force attack, only upside down. So instead of taking one account and hammering it with a whole bunch of passwords, you take one passwords and hammer a whole bunch of different accounts with it. But the difference, as you may have seen earlier also, is that you can spread the attack out. It doesn't have to happen right away. It doesn't have to happen against a single account. And it can do it to keep it under traditional alert thresholds. It takes that big data to analyze all of this and see, oh, look at what's happening here. It's not the sort of thing that a company can do on its own, like seeing what's coming in through the VPN. And as Sean pointed out this morning, there is this is the first alert about password spray from US CERT about that brute force attack. This is a slide that was stolen, repurposed from Microsoft, from TechEd, from I think Alex Weinert's session. I don't see Nitika in here. She'd be like, oh, I know that one. This is showing the distribution of a password spray attack from June 26th to, June 18th to June 21st. And so what you can see, each of these colors represents a particular password that's being applied. Big bump, settle down, smaller bump, settle, smaller bump, settle. This one in particular, some of them just appear once. But others, they continue and they come and go. So very spread out, very, very difficult to prevent. Now, you wouldn't be in here. AD is is vulnerable to password spray. And your users have reused their AD credentials because it's the easiest thing to do. It's a repeatable pattern. The password complexity filter doesn't comprehend common passwords. Third-party passwords, password filters do. Typically, they pull them in from different sources, either a straight dictionary or maybe they're now starting to pull them in from Have I Been Owned? But Azure AD Password Protection is in public preview. And that's my dog, by the way. That's Ripley. So, and yes, the naming of it is, it's a hybrid service, so they're calling it Azure AD Password Protection, but it's misleading because it does protect Active Directory. So what's the value prop in one slide of Azure AD Password Protection? Number one, it provides common password rejection at the domain controller. At the domain controller where the work is being done. 2, the banned password list is built from the intelligent security graph to form the backbone of the list. It's called the global banned password list. Microsoft gets 6.5 terabytes of signal per day across all of its properties to look at these, to build this list. It's a list of about 1,000 passwords. And as Microsoft says, the passwords on the list it comes from their intelligence of being actively used for attacks. So it's not theoretical. They build the list from what's actually happening. That 1.3 billion attacks like in August. Now you can augment that with a custom list. You can't see the global banned password list. But what you can do is you can augment it with a custom banned password list, or it's also called a tenant banned password list because it's tenant wide. So the idea is you're in a particular industry where your users may tend to use common passwords particular to your industry. So for example, the auto industry, Ford, GM, Chrysler, Mercedes-Benz, although I'm not sure I'd use Mercedes-Benz for a password, but anyway, you can augment it. It is a beautiful and elegant design, which I will show you. It does not require internet connectivity for domain controllers. It hardly even requires any corporate network connectivity at all. So any domain controller that can get to, if you can have one domain controller in your Active Directory forest that can access another server on your corporate network is all you need. And the rest of it works. And it's designed to not unduly load the domain controller. So oftentimes people say, well, why only 1,000 passwords? Why not, load 5,000, 10,000, 100,000 passwords in there and make it more secure? Well, it's not just the passwords. For every user that's trying to do this change, and you'll see, I talk about the algorithm in a minute, it runs against all sorts of variations of each one of those. And this processing is done on the domain controller itself. So you don't want to overly load the domain controller. So it limits it to, it's a Pareto analysis. They figure the top 10,000 passwords really gets you 99% of the way there. So we have two major areas here. So on the left, here's Azure AD, and on the right is on-premises. And we have here, this is a domain controller. This is another domain controller. And they replicate with sysvol right there. Over here we have proxies. And down here we have the administrator for the password protection, and over here we have the user that's working on password reset stuff. So let's dive into that in a little more detail. So the Azure AD part of it. So Azure AD, it does the basic service settings, and I think if you were in an earlier session, Sean kind of briefly showed it. It's basic service settings, the custom list settings, smart lockout settings. By default, password protection is turned on, but it's in audit mode. So what that means is as you install the password protection infrastructure, it will immediately begin reporting in event logs on people using common passwords, but it will let them do it. It's designed in sort of a fail-open architecture. So nobody gets prevented from doing anything as you install it and as you learn how it works. It's only after, when you're ready to actually turn it on, that it will start rejecting. And so you can see here, this is obviously just representation. Here's the global banned password list that comes from machine learning. Here is the custom banned password list that the admin can put in themselves. And these get put into a consolidated banned password list, which is what goes on premises. And to note here, Azure AD has banned common passwords for a while. So just for fun, let's go, let's see, where are we? Let's go here, and let's fire up, I'm a firm believer in the logic that the humans' typing ability goes down proportional to the number of people that are watching. So let's enter the password. So this is one that it's a newly created one, and it's waiting for the password to be changed. And so it is WULO0464. So WULO 0464. Okay. 64, and let's create let's use something near and dear to our heart. Pat asked, sorry about that, that was wrong. P at SSW0RD.
1.
Oh yeah, it's got to put a 1 on there. I got to put a 1 on there. Yeah, that's right, got to put the 1 on there. And I just muffed that one up. That's good, Sean. Let's see if this is going to work at all. P at SSW0RD1.
You didn't get the 1 on the top one. Middle one.
Thank you. We've seen that password too many times before. Choose something harder to guess.
It's errors kind of ambiguous, right? It's not, because you don't have visibility into what the pan word list is, the password. But now this says, this looks like more like a failing complexity. Okay?
It says we've seen that password too many times before.
History.
Possible.
And then is this only for the Azure account or also the on-prem AD account, home at a workstation and the workstation?
Right.
Password?
So the question is, the question that you're asking, if I think I know what you're asking, is what message does the user see? Right. I'll get to that and it will become apparent. Hopefully it will become apparent. So the proxy service. What is the proxy service all about? It's a simple relay service. It just allows domain controllers to get the banned password list from Azure without requiring internet connectivity. When it gets to the list, it forwards the list. When it gets the request, it forwards the request to the Azure Password Protection service. Then when the list comes down from Azure, it forwards it to the requesting domain controller. That's its purpose. Just to ensure that the domain controllers don't have to have internet access and give great flexibility in the network configuration.
So you're saying the password actually doesn't go out to the web, it's going to the PC?
The banned password list gets pulled down from Azure through the proxy to a domain controller.
Right, the passwords don't get sent out to the cloud. And
Correct.
come back.
All password processing is done on the box. Yeah, Jay Simmons, who is a senior developer lead, I always get confused in the titles, but he's a senior Active Directory developer, designed this, and it's an elegant design. Yes.
And the proxy service can be installed on domain controller. It can be installed anywhere.
It can be it can be installed on any domain join server.
Okay.
It's very lightweight, as you'll see the requests. I'll show you the commonality of the requests. In public preview, it's in public preview right now. It supports 2 proxies for high availability, and they'll plan to have more when it reaches GA first quarter next year. Worth thinking about though is this is a little bit like Azure AD Connect in that it's an important service, but it is not it's an important but not a highly time-sensitive service. It's not like these banned passwords are going to need to be updated on a minute-by-minute basis or anything like that.
What is the request? What is the banned password request? Is it
I'll show you. The bits are in the download center. Just look for Azure AD Password Protection. It's what comes as part of the download as both the proxy and the on-DC agent. And to do this, you have to register the proxy service and the target Active Directory. So what I'm going to do is I'm going to pull up my proxy here. And I'm not taking the time to actually install the proxy service on there. It's not particularly interesting. You guys have all seen, and gals have seen MSAs all the time. I do want to point out one little thing, though. If you're working on installing this and reinstalling it, one of the things that has to be in there is you use a PowerShell module. And so you need to look to be sure that this is in place. And let me just zoom in on this. I'm being defeated. I can't run zoom it because then I should have put zoom it on there. Anyway, basically, it adds the password protection service, you can see it down there at the bottom, into the environment variable to tell PowerShell where to look for modules.
That's on HDC?
No, this is just on the proxy servers right now. I haven't gotten to the DCs yet. So let's take a look at the service. I'm sorry?
You missed it.
Yeah, thank you. Get service, not a lot to see. Just very clearly says Azure AD Password Protection Proxy. So what I will show you though is in the event log. So the event log, it installs a new application or a service log item for password protection. If I could figure out a way to make that larger, but and I'm under the proxy service operational. So what I have already highlighted one right here. I didn't highlight an installation one, but this shows right here where the Azure AD Password Protection Proxy, too many P's, forwarded a message to Azure on behalf of the calling domain controller and received a successful response. So that's the process. It just acts as a relay, up and back down again. And so the first time that you register this, they warn that this may take a while. I've had it take a while and I've had it not take a while. So what you've just done is you've just validated that proxy service, when it's asking password protection, that it is valid. That's, it's allowed to make the query and get the information back. There's a twist on this in public preview. It requires global administrator to register it, but they don't have the code in there right now for global administrator with multi-factor authentication. So you have to take off MFA for the global admin that you do the registration for. And everybody's in a snit about it, I know, but the reality is, A, public preview, not supposed to use it in production. B, set up a global admin account, enable it, register it. You saw how long it took. Delete the global admin account. It's not perfect, but they promise that will be available upon general availability. The next thing that you have to do is you have to register the forest that you're doing this with the service. Not properties, just go there. So register -Azure AD Password Protection Forest. This time it's prompting for my domain admin credentials. And it's done. Not too dramatic.
What do you reckon is going on when you register your force? What is it actually doing? It seems odd. I mean, I can understand registering the proxy, if that makes sense. I'm not sure about registering the force.
Well, I mean, you can have, so you have to have one of these service infrastructures per forest. So it's possible that it's using to distinguish them between forests, multiple forests inside one tenant.
Would it be that it would be also used in the trust passwords?
I'm not sure I understand.
Oh, to check the trust passwords. I wouldn't think so.
Those
are automatically generated.
Yeah, it doesn't.
Well, I mean, it would be established in the trust.
It's not doing any. Well, I mean, not in the sense of a forest trust, you mean, or no? This is not using that kind of a. It's not using that kind of a mechanism. It's leaving it.
I don't think that goes through the password filter.
Which, the forest trust?
Yeah.
No, I don't think so. So, the DC agent and the password filter. So this is the heart of the system. It comes in two parts. The DC agent does most of the heavy lifting. It does all of the heavy lifting. So this is the software that does the password evaluation, and it manages the banned password policy. This is the thing that asks for the password policy from Azure, and then will also create the policy, which it puts on sysvol. So let me show it here. So on the domain controller, here's the DC agent, and this is the password filter for the DC agent in LSASS. The password filter is, Jay Simmons says he made it as simple as he possibly could. All it does is forward the password request to the proxy. I mean, to the agent. That's all it does. The corollary of that, though, is that when you install this, you have to reboot all the DCs that have it because you're installing a password filter. And then there is the DC agent service, and the password filter passes the password validation request to the agent. The other thing the agent does is, as I said, it has this banned password list, and what it does is it creates a policy, like a group policy, only it's a password policy that gets written to sysvol. Now, the beauty of that is that once that policy is on sysvol, the other domain controllers that have the service on it look for the policy on sysvol, and it'll automatically replicate, and they automatically get it. So the other DCs don't have to do anything. One DC can do the relatively lightweight work of making a policy out of 1,000 passwords, and then it just gets passed around to the other DCs in the domain and in the forest. And I just talked through this, more or less. So the DC agent checks for a current policy on sysvol. They check one domain controller per site per hour, checks for the policy to see if the policy is current or not. If it doesn't find a policy, like the first time, it requests a banned password list via the proxy. And you just saw that request out and back. Once the password is created, once the policy is created, it's distributed via sysvol. Now, so this is designed to be very, very, very low impact that way. Yes?
What information is in that password policy thing?
I don't know. I haven't seen the inside of it. So.
Is it more readable?
No. I'm sorry, is it what readable?
The password policy file in the sysvol, does it have like a specific ACL, like the users can actually read it?
Yeah, I have not looked at that. That's a great question. I'll take a look when I get a chance, actually.
Sounds like a new attack path of let
And the authentication flow is as what you see here. The user contacts the domain controller. This is all pretty standard. The password filter passes it to the DC agent. The DC agent evaluates it, does an approve or reject, and success or failure is returned to the user. And this is the Achilles heel. This is both the benefit and the pain of this. Because it uses standard DC mechanisms, there's no way to tell it you have too common a password. So one of the things that you have to do with this is user communication. So this does increase pain in certain circumstances, because all it says is the same message that's always returned. Your password did not meet complexity requirements. I'm sorry?
How long is the evaluation take? Is it noticeable?
No, I mean, no, it's very fast. It's the same. It doesn't take any longer than it would for a regular evaluation.
How often is the BPA refresh on site?
Once an hour. It's checked. One DC per site per hour will check for an updated list. And in the real experience, what turns out is it's very, very low, because that's one DC per site per hour that checks it. But then sysvol replicates it everywhere. And so another DC and another site will wake up and go, oh, no, I've got a recent version. I don't have to do it. So it's like one DC per domain per hour typically, unless you've got a really segregated network. So this password evaluation process, this is how passwords are evaluated. And this came from they did an Ask Me Anything on Reddit about it. So this is, but it will change. These guys will change things as people have these vectors and all that. So what is the process? So first, there's a coarse-grained evaluation. Is it just a batch? Does it 1, 2, 3, 4, 5, 6? Is it in the banned password list? If not that, does it match after character substitution? Because let's face it, we all know character substitution doesn't work anymore. Then a fine-grained evaluation. So the minimum allowable score, it's done on a point system, is 5 points. And here's that same string that we've seen before. So let's say the substring is Spring 2018 ASDF J236. So it finds 3 substrings in there that are common. Spring, 2018, and ASDF. Each of those gets scored 1 point. So that's 3 points. Then the remaining characters, 1 point each. So that's 4 points. So that's a total of 7 points, and then they allow it to pass. So the idea here is not to be draconian hard on the user, not to make it really, really impossible, but just to make it a little bit easier. The bottom line is there's only so much that can be done, and there's only so much pain you can put on the user. So they dialed it back a little bit. A couple notes: the global password list and the custom band password list, when it's doing a password check, they're not currently being combined into one list when it's doing a password check. It'll check for one and not check for the other.
What?
So it will if you have a substring that has both the master band password that contains that and contains some of your custom ones, it will check for one, but it won't check for the other. It won't combine those and say, oh, here's only 1 point because I saw this in your global, and here's only 1 point because I saw this in your local. It's a bug, and they're working at it. So that's the idea, of course, is that it all be munched together and it all work that way. So let's quick do an evaluation and show what this looks like before they get out the hook. So this is on my domain controller, and I'm going to pull up. I'll clear that out. So can everybody see that more or less? Good. Okay. So let's do a net user 1, and this is just the regular password complexity filter because it's not complex enough. So if I do something like net user, I'll do my p at SSW0RD1. Now that will pass the Active Directory complexity filter. But it won't pass the band password filter. Now what I've created a custom list in Azure AD that contains some words from the auto industry, Chrysler, Mercedes-Benz, that sort of thing. So what I'm going to do is I'm going to create one. I'm going to say CHRYS 1 for L, E, R with a bang on the end of it. That would pass the AD password filter. Oh, did I spell it wrong? CHRY.
Yeah, 1L.
Oh, yeah, you're right.
E1.
Yeah, CHRYSLER. There we go. Boop. Didn't allow it from the custom list.
The agent running on the PC, does that at least log an event saying
Yes.
tried to do a password reset, but the Azure.
I would give you a cookie if I had a cookie to give you. So this is an example of the error log message that shows when you first turn it on in audit mode. This is saying that user would have failed, but it's in audit-only mode. So you can go and look, and you can see what users are failing on it, but are not being affected by it. But if I go up to the top, and actually if I just do a refresh, and it just says the reset password for the specified user was rejected because it did not comply with the current Azure password policy. Please say the correlated event log message for more details. This is the correlated event log message. It just says very similar. It says, was rejected because it matched at least one of the tokens present in the per tenant banned password list of the current password policy. So it hit the Chrysler. Oh, sorry, do you want me to bring it back? All right.
I have a
there a minimum domain, AD version? Functional level? Anything.
2012 or above. Oh, I'm sorry. I meant domain controller operating system version. I don't know that specifically, but I see no reason why it should have anything to do with it. It's what's happening on the DC.
I think the documentation says 2008 R2 minimum.
R2 on the domain controller, you mean, or the forest?
I don't know.
Yeah. Okay. One of the things to note, though, on this is that because it uses DFSR, let me just back up. How many of you are still using FRS for sysvol replication? Yeah, right. We've outed you. Well, so you now have an excuse to go to DFSR, which you may have needed in the past. I don't know. And so, kind of as a sort of an overall, and this was a discussion that Nitika's here. I had a discussion with Alex about this. As death to passwords, man. This is only a Band-Aid on it. You can't treat this as the whole solution by any means. It's only one vector. All the other weaknesses still apply. MFA by 99.9% reduces attacks, and that's from Microsoft evidence. Automated risk policies, which is identity protection, 96%. Pricey, but 96%. What's the cost of security? Blocking legacy authentication reduces compromise by 66%. So there's a great driver for your security people, your CISO, to start upgrading Office or getting rid of some old stuff. Deploying Azure Advanced Threat Protection. How many of you are familiar with ATA or Azure ATP? So this is the stuff that monitors your domain controllers for traffic and monitors them for deterministic attacks and user behavior attacks. And then Cloud App Security, as Sean was talking about briefly this morning, another super powerful tool when you've got a bunch of cloud applications, and especially you have the first-line cloud applications that support APIs like Box and Salesforce and some of these other things to protect your SaaS applications as well. And they very nicely put a little graphic up there so you can take a picture of that, and that's got their basic recommendations for securing your infrastructure. And even then, it's easy. It's aka.ms security steps.
I'm kind of curious, has anyone been successful in turning off NTLM in their environment?
Crickets?
Yeah,
Bueller?
you're saying turn
Anyone?
it off, turn it off of.
I've got like 3 or 4 task force without it.
Scary thought, isn't
I'm just curious.
Yeah.
I haven't heard of anybody.
Nope. Anyway, to summarize, password spray attacks are dramatically on the rise. The last time at the MVP Summit, they were like wide-eyed, like, oh no, you guys, you really need to drop everything and get stuff behind MFA. Obviously, AD is vulnerable to them. Password protection is a good way to protect yourself against it. And evaluate it today. It's still public preview, so you can't. Well, you can. It's been pretty solid for me, but then I don't run it in a production environment, against a bunch of domain controllers. But I would absolutely put it in some of your testing environments and kick the tires and provide feedback. If you run into things, that's the whole point behind public preview.
Is this supported in a test environment that's not connected to an Azure AD?
You have to have, the beauty of the proxy is you have to have one domain controller has to be able to reach a proxy. So if you're in an isolated environment, I'm sorry?
No, it's not isolated. It's just that not doesn't have Azure AD available to that domain.
Yes. No, that's the whole point behind the proxy. It makes it very easy. You could theoretically have an AD forest in an isolated environment and open a firewall rule from one domain controller IP address to the proxy IP address over 443, pretty sure, and that's it. and then you'll get password protection on that
But
environment.
it has to be associated with an Azure AD.
Wherever good slides are sold. I'm not sure where they're going on the conference, but all of these, and video recordings too. So you can look at my facial tics at your leisure. Thank you.